Assalamu alaikum students, welcome back to my channel Carbonate. So today we shall continue with a new paper practice of past paper, and today we are going to attempt the May-June 2025 paper of chemistry paper 1-1. So now let's start with it without wasting the time. Our first question, that is, ICl3 reacts with water in a redox reaction, and this is the equation provided here. We have ICl3 reacting with the water to make HCl, HI, HiO3 and HClO3. Now the question states, what are the numbers V, X and Z in the correctly balanced equation? So basically for this question, we are supposed to find the coefficients for this chemical equation. Now, if we look at this equation, we can see that we have two types of iodine mentioned on the right side and two times of the chlorine mentioned on the right side. And these are the only element that must be balanced properly. So even if you try to use the oxidation numbers method, let's suppose I will say that it's -1 over here. Chlorine, one chlorine atom has -1 oxidation state, times 3 will give you -3, and iodine will become +3 here. And on the right side, the chlorine is -1 over here, hydrogen is +1. Iodine versus H. Now this side becomes totally confusing, that which element should we assign plus oxidation state and which element should we assign negative oxidation state, because as we move down the group in group number 7, the oxidation state values decreases. For example, for fluorine we have 4.0, for chlorine we have for chlorine we have 3.0. Bromine would have less NS. So we do not know what shall be the value for the iodine, but the value of hydrogen is 2.1. So it's almost a kind of a non-polar, I would say, bond. So it becomes not clear. It doesn't. We are not clear which element has plus state, which element has negative state. And on the right side, we have HiO3. Now we know on the oxygen, we should have minus. The overall charge on the IO3 should be -1. So the hydrogen would have +1. That means the state on the oxygen will be -2 times 3 to give -6. This shall become -6. And the iodine would have +5. Similarly, chlorine will have +5 over here. Now, because of this reason, we cannot balance this equation by using the oxidation numbers. So instead of using the oxidation numbers, we will simply use the combinations of the coefficients that are provided in the table. So let's start with the first combination that says V is 2, X is 8, and Z is 1. There are two Z's here. Now, according to this, you can just simply count the number of chlorine atoms on each side. So on the left side, we have 3 times 2, 6 chlorine. And then on the right side, we have 8 chlorine from this side. And then 1 chlorine from the product HClO3. 1 chlorine from this side. So in total, we have 9 chlorine in the product side, whereas there are 6 chlorine on the reactant side. There is no other substance on the reactant side that should add chlorine. So we could say A is not the correct answer. Now we check the second combination that says 251. So I will raise it and replace it with 5. Now on the left side, chlorine will remain the same, 6 chlorine, but on the product side, we will have now 5. We would have 5 chlorine coming from this side, 5 chlorine from this side, and 1 chlorine from this side. So this will give us 6 chlorine. Now we have equal number of chlorines on both sides, but if we check the iodine, then we can say that there are 2 iodines. So by checking the number of the iodine, I would say that we have the 2 iodine present here, and this will give us 2 iodine over here. And with respect to hydrogen, let's check on the right side, but how many hydrogen atoms are there on the right side. So 5 hydrogens, sorry, we'll check the oxygen first on the right side. We have 3 oxygen atoms coming from here, 3 oxygen atoms coming from here. So 3 plus 3 is equal to 6 oxygen atoms on the product side. Now to balance this 6 oxygen, we need 6 to be replaced with W, give us 6 oxygen atom. Now with respect to oxygen, they are balanced. Now we check the hydrogens. So they are 6 times to 12 hydrogen atoms on the reactant side. To balance it, we need to have 12 hydrogen atoms on the product side. So we already have 1 hydrogen atom coming from here, 1 hydrogen atom coming from here, and 5 hydrogen atoms coming from here. That means we need to put 5 instead of Y. So 5 times 5 plus 5, 10, 10 plus 2, 12. So now hydrogen atoms are also balanced. But if you check here, there are now 5 hydrogen. We have 5 iodine atoms from this point and 1 iodine from this point. That means 6 iodine. So 6 iodine on the product side, but on the reactant side, we already had 2 iodine because we had to balance the chlorine at the start. So that means this reaction is not properly balanced with respect to the iodine atoms. The chlorines are balanced, hydrogen are balanced, and oxygen are balanced, but the iodine is not balanced. So this is how we got it incorrect equation by using these coefficients. So B is incorrect. Now I'm gonna erase all these to substitute new numbers and check the number of atoms of the other elements. Now C says it's 3 over here, it's 8 over here, and 1 over here. Now check the chlorine atoms. 3 times 3, 9 chlorine. And the product side we have 8 chlorine and then 1 chlorine. So the chlorine atoms are balanced. Now we check the number of the iodine. So the iodine on the reactant side is 3 iodine from here. On the product side, we have 1 iodine coming from this point. Now, but before going to that, we will first check the oxygen atoms again. So we have 3 oxygen atoms coming from here, 3 oxygen atoms coming from here. So again, you will have 6 oxygen atoms on the product side. To balance it at 6, we need to put 6 over here, and that gives 6 oxygen atoms on the reactant side. Now, with respect to hydrogens, there are now 12 hydrogen atoms on the reactant side. To balance these 12, we should have similarly, we already have one hydrogen atoms coming from these two compounds and 8 hydrogen atoms coming from these. So that means we already have 10 hydrogen atoms. So I will just put 2 over here. Sorry, I will just put 3 over here. So this will give me 8. I will put 2. So 2 is here. Now 8 plus 2, 10 plus 2, 12. 12 hydrogen atoms, they are also balanced in this way. And 12 hydrogen atoms on the product side, 12 hydrogen atoms on the reactant side. And with respect to iodine, we have 2 iodine coming from here and 1 iodine coming from here, because the blue one was already there from the start. So we have 3 iodine, and there were already 3 iodine present in the reactant side. So you could say that all the elements have now properly balanced if you put these coefficients mentioned in the C option. So C is the correct answer. Now question number 2, the total volume, the rate of the diffraction between a reactive metal and excess of the dilute acid is investigated. We have this table provided in which the amount of the hydrogen gas liberated by the reaction between the metal and the acid is investigated. And we have the values for different intervals. They are asking for us to find the value for P minus Q. And P is the rate for first 30 seconds, Q is the rate for last 30 seconds. So what we need to do is that we have to separately calculate the values of the rate of the reaction for the first 30 seconds and for the last 30 seconds. Now I'm going to calculate that value. The P is stated as the average rate for the first 30 seconds. That means it should be, you should remember the rate is always represented as amount divided by time. This is the formula to find the rate. So for P, which is first 30 seconds, I will write, we have 60, we have first 30 seconds. These are the first 30 seconds, and the amount of the hydrogen gas liberated in these is 64 minus 0. 64 minus 0 is equal to 64 cm cube liberated for the first 30 seconds. So I will write 64 divided by 30. When you do this calculation, you get the answer equivalent to 2.11, 2.133. And this will keep going on. This is the rate for the first 30, and definitely it is cm cube per second. Then Q is for the last 30 seconds. Now the last 30 seconds are over here, and the rate and the volume liberated for 30 seconds should be minused from 167. So I will write Q is equal to, again, amount should be in the numerator. Now this time it is 167 minus 161 divided by, again, 30 seconds. Either you just write 30 or you could write 180 minus 150. That will still give you 30. So it will become 6 divided by 30. And when you do the calculation, you will get 0.2 cm cube our second. All right, so we have got the values for P and Q. Now what you need to calculate is the value of P minus Q. So P minus Q will be equivalent to 2.1333 minus 0.2, and the answer comes out to be 1.93, and that's the correct answer, which is in this question is B option. Now question number 3. In the diagram, curve X was obtained by measuring the volume of oxygen produced during the decomposition of hydrogen peroxide, and manganese peroxide is used, which is acting as a catalyst. We have this graph in which we have two different curves, y and x. We have to see which alteration to the original experiment that represented x must be weighted so that you will get the curve y. Now what we see here, that we have the x as a original experiment, and we have to convert it into the y by doing some alterations. So we see that in the experiment Y, there is more amount of the oxygen produced. The volume of the oxygen produced in the second experiment is greater. So which experiment change should increase the amount of the oxygen? If we say that, let's suppose which is A, adding more manganese peroxide, then we should remember that A is simply the catalyst. It is not a reactant, so it is just a catalyst, and catalyst only increases the speed of the reaction. So if we, let's suppose if we add manganese peroxide, it will just increase the rate of the reaction, and that's all. It will still increase more amount of the rate, so it will increase more speed of the reaction, and still the graph will come at the same point of x. There will be no effect of manganese peroxide. If we say adding water, then if you add water, then you are basically reducing the concentration of the hydrogen peroxide, because hydrogen peroxide was previously equivalent to 100. If you apply the formula, N is equal to C into V over 1000 to get the number of moles of hydrogen peroxide, and the number of moles will decrease if you add more amount. So decreasing the concentration reduces the rate of the reaction. So C will not affect, it will reduce concentration, or you could say it will reduce the mole, reduces moles. D say raising the temperature. We are not familiar which type of the reaction it is, whether it's endothermic or exothermic, and whatever there is, it will still have no effect on the amount. It will only increase the rate of the reaction, especially for all the reactions. The rate of the reaction increases by increasing the temperature, and that again have the same effect on the graph as explained for the adding manganese peroxide. So we could say that temperature, increasing temperature, and adding more catalyst will have the same effect. So it will not be the reason. The last one is adding the 0.1 mole per dm cube of hydrogen peroxide. So this could be the reason, because you are actually increasing the amount of the reactant. So when you increase the more amount of the reactant, and that the reactant is the reactant is being decomposed in this reaction, so it will increase the value of the oxygen produced by the decomposition. We know that it is reaction like this: H2O2, when decomposed, it produces O2 plus H2O. And one more thing, if you look at the C option again, although it's a wrong option, if you look at C option again, Then C option states that you add more amount of the water, but the water is a product here. It's not a reactant, so there will be no effect of it. So C is not the correct answer. The only option is B, because you are basically increasing the amount of the H2O2. And if you increase the amount of H2O2, that means you are also increasing the amount of the O2 by decomposition. So B is the correct answer. B is the correct answer. Now, question number 4. The first 7 ionization energy of an element between lithium and neon are represented here. We have to tell the electronic configuration of that element. So if we look at the differences, that will tell us how many valence electrons are there in that element. So there is a jump from 1300 to 3300, then 5300, then 2400, 11, and we have then uh, 11,000, then 13,000. So these differences are not too big, but the difference from 13,000 to 71,000 is a very large jump. So by looking at this large jump, we can say that this is the 6th ionization energy. This is the 6th ionization, and that means there are 6 valence electrons present in that element. So we are also saying that that element is present between the lithium to neon. That element is present somewhere in between these two elements. Lithium is atomic number 3, neon is atomic number 10. So if there are 6 valence electrons, then the electronic configuration should be having 6 electrons in its valence shell, because these two elements belong to second period of the periodic table. And if there are 6 electrons present in the valence shell, those should also be present in the second period. So the only option according to that is 2s2, 2p4. That gives the 6 electrons in the valence shell. The D option indicates 8 electrons, that belongs to neon. B says 3 electrons, that belongs to boron. And A says 2 electrons, that belongs to beryllium. So C is the correct answer. Now the question number 5, the reaction of hydrogen with oxygen is shown in this reaction. We have to express this equation according to the expressions given in these 4 options. Now, if we start from the B option, that says it is equivalent to enthalpy of combustion of water minus enthalpy of combustion of hydrogen. So basically, if we look at here, this equation has 2 moles of the water here. So the enthalpy of the combustion must have been multiplied with 2 over here. Sorry, it should be formation of, it should be written as enthalpy of formation of the water, and it should also be multiplied with 2. That should be a correct expression to represent the water. So it's totally incorrect. The C says it is enthalpy combustion of hydrogen. So we again see that there are 2 moles of the hydrogen that have been combusting with the oxygen. So it is wrong. And one more thing, if we look at the B option again, we were supposed to represent the equation for the formation, because water is being formed. It is not being combusted, it is being formed. D option says it is 2 times of enthalpy of formation of water. So up to this point, that is correct. And then it says plus 2 times of enthalpy combustion of hydrogen. Up to this point, it's also correct. But the thing is that this plus sign is not equivalent for this reaction, because whether you are supposed to write only the right side or the left side only. But here they have written this is the reactant side, this is the product side. So if the enthalpy was supposed to be written, it should be only the reactant side having the enthalpy of combustion of hydrogen, or it should be only the enthalpy of formation of water. But in the D option, they have mentioned both sides, so that is wrong here. And the A option says it is the enthalpy of formation of water by 2 times. So yes, that is correct. We have water formed in the product side and there are 2 moles of the water formed. So enthalpy of formation of water is multiplied by 2. So that's why A is the correct option. Now the next question, number 6. In this question, we have P is a compound that burns in an excess of oxygen to give this carbon dioxide and water, and we are provided with the mass of the carbon, mass of hydrogen present in that P compound, and the P also reacts with the sodium carbonate to produce bubbles of gas. Now, we have to remember from the knowledge that the compound which reacts with the sodium carbonate produce gas is the carboxylic acid. So it is confirmed that P should be the carboxylic acid compound, in short form RCOH. Now, among these 4 compounds provided, A is the aldehyde, so it is not in our list. The C is an alcohol over here, so it's also not in our list. So these 2 options are opted out. We are now left with B and D because both B and D are carboxylic acids. Now here we have to determine the right answer from these 2 options. So for this purpose, we first need to use the details already provided in the statement that it says 2.20 gram of the P contains this much gram of carbon and this much gram of hydrogen. So we simply take the percentage values. So I'll write it here, the percentage of the carbon in P compound is represented as 1.20 of carbon divided by the total mass of the compound, that is 2.20. Now this gives me the percentage equivalent to 54. You need to multiply with 100 as well. 54.54%. 54.54% is the percentage mass of the carbon. Now, without going into further calculations, I'm gonna switch directly to the compound D, in which we have the carbon. We need to find the molecular mass of this full compound D. Here we have the 4 carbon atoms, plus we have 8 hydrogen atoms, and then 2 oxygen atoms. Now the value, MR value of this whole will become 88 MR, because we have to match the same percentage of carbon with that of the already present 2 compounds. We have the ethanoic acid and the other one is butanoic acid. So I'm going to use these values. Now out of the total mass is 88, MR value is 88, and out of this, the mass of the carbon is equivalent to 4 times of carbon. So 4 times into carbon mass is 12. So it gives me 48. That's the mass of the carbon. 48 gram of carbon. So I'm going to calculate the percentage of carbon in D option. Percentage carbon in D is equivalent to, that is basically butanoic acid. It will give me 48 divided by 88 times 100. And this will again be equivalent to 54.54%. So just by matching the values of the carbon, we can clearly say that D is the actual compound. P compound is basically D. You can also confirm your answer by doing the calculations for the B compound, and when you will do, you will see that percentage carbon in the compound ethanoic acid in C will be, the mass is will be 24, and the MR value that compound will be 60, and that percentage will be equivalent to 40%. So that's not equivalent to the 54.54%. That's why D is the correct answer. Now the next question, number 7, substance W has a physical properties shown. We have these properties provided for the compound. We have to match the compound with that of these properties. So if we look at here, the electrical conductivity will help you to find that answer. If let's suppose we say that's the B, then B is a metal and the conductivity of iron in solid should be good. So it says poor here. That means it's not an iron. So B is wrong. C says silicon dioxide. If it is silicon dioxide, it is a giant covalent compound, then the conductivity of silicon dioxide should also be poor in the liquid form. That's also wrong. D says sodium fluoride and A says aluminum oxide. Both are ionic compound. This is also ionic compound and this one is also ionic compound. But if you remember the solubility, then you should remember sodium fluoride has Na plus 1 bonded with the F minus 1 fluoride minus 1. On the other hand, aluminum is Al plus 3, which is bonded with the oxide minus 2. There is very strong ionic bond in the aluminum oxide because of very high charges present both on the metal and the non-metal. On the other hand, sodium fluoride has only one charge on sodium, also one charge on the fluoride. That means if you try to dissolve NaF into the water, it will be soluble. NaF is soluble in water, but aluminum oxide is insoluble because of very strong ionic bond present within the aluminum oxide. So if we match these values, if we match these details that present in the table, we see that it is insoluble in water. And with respect to the conductivity, so aluminum oxide when molten, the liquid form is basically the molten state of the compound. So yes, it is a good conductor. Ionic compound is a good conductor in molten state, and also in the solid state it is a poor conductor because we know that the positive and the cations and anions are held in place very strongly. So since they are strongly held in place, they are poor conductor at solid state. So that's why we can say what happened. We can say that A is a correct answer. A is a correct answer. Now, next question, number 8. Which diagram represents the lattice structure of the sodium chloride? Now, here in this question, we have to correctly identify the structure of the sodium chloride. Now, basically, the D option is not the correct answer because it's the structure of the metallic atom, metallic element or metallic bonding, whatsoever you call it. So D is wrong. The C indicates that the cation is larger, anion is smaller, and the B says that anion is larger and cation is smaller. So basically, if you remember sodium and chlorine, the sodium will need to convert into sodium ion, and when it does, it has to lose valence shell. That means the size will decrease. The size of the sodium ion decreases, and that of the chlorine, it has to convert to chloride ions. So the size increases because of an extra electron being added into the same shell. That increases the repulsion forces. Repulsive forces increases in same shell. So that's why the size of the anion is greater as compared to its parent neutral atom. So C becomes wrong because here cation is greater and anion is smaller. So that's why this is wrong. The size is wrongly mentioned. Now what about A versus B? The A says that sodium is smaller and chlorine is greater. That is so only if they were in their ionic form. In the ionic form, that is correct, but not in their atomic form. If we consider only atomic form of the sodium versus chlorine atom, then sodium is greater in size and chlorine is smaller in size. But here it is not represented correctly. One more thing, within the lattice structure, we should remember there are ions present in the lattice structure, not the atoms. The atoms are not correctly identified, or we could say the atoms are not present in the lattice structure. In fact, there are the ions that are present within the lattice structure. So in both ways, A is incorrect because they should represent the chloride ions, sodium ions and chloride, and that should be the correct answer. On the other hand, the B says these are the cations and anions present, and their sizes are also correctly indicated. The cations are smaller and anions are bigger. So that's why B option is a correct option. Now, question number 9. An aqueous solution X contains substance HU which behaves as a weak acid. We have the equation, and then it says that when soluble salt NaQ is added to the compound, is added to the solution X, what will be the changes in terms of hydrogen ions and in terms of pH? So basically, the NaQ, when dissociated, it shall produce the it shall not be the equilibrium equation because it is a sodium salt, so it will only be producing the irreversible arrow, and it shall produce sodium ion and two anion. So basically, Q ions are similar as compared to the already present equation that also contains a Q ion. So when you add NaQ, you are basically increasing the amount of the Q anions here. Q anions are increasing when you add NaQ. So according to Le Chatelier's principle, we should know that if you increase the amount of any one substance in the equation, then it has to minimize and oppose that increase. So to minimize or to oppose that increase in the change of Q anion, it should move towards the left side. So equilibrium will shift to the left side to minimize that amount of Q negative ion. And how does it minimize? It will minimize by reacting with the hydrogen ion. So Q ion will be reacting with the hydrogen ions so that it will move towards the left side. Now when it does, it will also decrease the amount of the hydrogen ions because this is the only thing which is reacting with the Q negative ion. So hydrogen ion amount should decrease. So from the first column, it should be the decrease in the amount of hydrogen ions. Now, if you remember from the chapter that concentration of hydrogen ions is represented with the amount of the pH as opposite effect. If the hydrogen ions amount increases, it means more acidic condition there is, more acidic. And by more acidic, it means the pH value will be smaller. It's an inverse relation. Hydrogen and more means less pH. But here, we are decreasing the H plus ion by increasing the amount of Q anion. That means if you decrease hydrogen ions, it means the pH value should increase. So from here, we say it is the increase in value of the pH. So there are two ticks in the B option. So that's why B is the correct answer. Now, next question. Question number 10. Dinitrogen tetroxide has this decomposition equation. And then we have the two substances present in the equilibrium in closed container, and the Kc value for this reaction is mentioned. This is a Kc. The conditions were changed somehow, and under that change, there were a different value of the Kc. There was a different value of Kc under that condition. We had to tell what change was there. So if we compare these two values, Kc, this Kc versus this Kc, you can see that after changing the condition, the value has been increased. It has been increased if we compare it with the 1.15 into minus 1 versus 1.7 to minus 3. That means there is a very increase in temperature. There is very increase in the value. So basically, if you remember from the equilibrium chapter, the value of the equilibrium constant can only be increased if we increase the temperature, and especially here when the enthalpy is also endothermic. The enthalpy is endothermic, and if we increase the temperature, then the equilibrium will shift towards the right side or towards the product side by increasing the temperature. The equilibrium shifts to the right side, and that will increase the value of the Kc. How is that possible? Because we know the Kc expression is written as the concentration of the products divided by concentration of the reactants, and in this case, the product is NO2. So the value increases for endothermic reaction. The concentration of product increases in the endothermic reaction, and that will increase the value of the Kc by increasing the temperature for endothermic reaction. So that's why the correct answer becomes a option C. C is the correct answer. Now the next question, question number 11. We have this volume of sulfuric acid and concentration, the volume concentration of NaOH. They are reacted, and before reaction the temperature is 20 degrees centigrade, and after reaction it's 29. And then we are provided with a specific heat capacity. We have to determine the enthalpy of neutralization. Now for this purpose, we need to convert these values of the volume and concentration of sulfuric acid and NaOH into their respective moles. Because we remember the formula to calculate the enthalpy is delta H is equal to minus mc delta T divided by N into 1000. This is a formula to calculate the enthalpy G. Now we need to know what's the value for N. Now N is basically, as we remember, it's the reaction between acid with base to produce salt and water. Now the value of N should be equal to the value of the number of moles of the water produced in this reaction. So after knowing the reaction, the number of moles of the water should be calculated. That will be the value for the number of moles mentioned in this formula. Now, for this purpose, we will now convert the values of sulfuric acid into moles. So, number of moles of H2SO4 is equivalent to C into V over 1000. Putting the values 1 into 50 divided by 1000. That gives us 0.05 mole. Similarly, we calculate the number of moles of NaOH. That is equivalent to 1 into 100 over 1000. it is equivalent to 0.1 mole. Now we need to check the moles of the water produced by each of these two. So let's take the ratio method. Sulfuric acid ratio water. For that purpose, we need to have the balanced equation. So the balanced equation of reaction of NaOH with sulfuric acid is written like this. We have Na2SO4 as is salt plus water, and there are 2 moles of water produced. We have to put 2 over here. Now the equation is balanced. Now according to the ratio between sulfuric acid and water, I will write here H2SO4 ratio water. Basically, if you recall the definition of enthalpy of neutralization, it was that when 1 mole of the sulfuric acid reacts with 1 mole of the NaOH to produce 1 mole of the water. So it is basically related to 1 mole of the water that has to be produced in the neutralization. Now we have 2 moles of sulfuric acid. We have 1 mole of the sulfuric acid in the balanced equation, but we have 2 moles of water produced. The calculated value for moles of sulfuric acid is 0.05. Now in that case, water become X. So after cross multiplication, X value will be equivalent to 0.1 mole. Now similarly, take the ratio between NaOH versus water. We have 2 moles of each. And if there are 2 moles of each, that means the number of moles of NaOH will also be equal to moles of water, 0.1. Now, in both cases, we see that there is 0.1 mole of water produced in both cases. So that means the value is not changed. That's the value of N. Now, we use the formula delta H is equal to minus M. Now, the value of M is basically the value of the volume of the 2 solutions. We have 50 cm cube coming from the sulfuric acid and 100 cm cube coming from the NaOH. So we add these 2 values together. So minus M will be equivalent to 50 plus 100 into concentration. Now C is the enthalpy heat, specific heat capacity, that is 4.2, already mentioned in the question. And delta T is Tf minus Ti. So Tf is 29 degrees centigrade and Ti is 20 degrees centigrade. So 29 minus 20 is a temperature change. 29 minus 20, that's a temperature change divided by moles into 1000. Now moles is same in both the cases. So we put 0.1 here into 1000. The answer will be equivalent to minus 56.7 kilojoule per mole, and that's the right answer from option B. Now the next question, number 12. Barium dithionate compound formula is this. It's soluble in water. This is the decomposition of S2O62 minus. And then we are provided with the mass of barium dithionate in 100 cm cube volumetric flask, and acid is added. Then we have the white precipitate of 0.661 gram present in the flask, where we have to determine the concentration of BaS2O6. Now, this question demands calculations, and so we have to do some calculations here. So first of all, we should understand the concept here. The concept says that this barium dithionate dissociated in the water because it is soluble, and within that, the S2O6 2 minus also dissociated. And at the end, we have the white precipitate formed of the mass this much. Now, basically, this mass belongs to barium sulfate because white precipitate is a barium sulfate. And how was it produced? Because there was sulfate ions present in the solution, and there were also solubility of this compound that produced the barium ions. So barium plus 2 ion, when reacted with the sulfate ion, it produces the barium sulfate. So that means this is a amount that has to be taken out from the uh, barium dithionate because this much amount is not dissolved. This much is undissolved in the flask, and we have to determine the concentration. So that would only require moles that are dissolved divided by the volume, because we know the formula C is equal to N over V. We will use this formula here. But before going into that, we need to convert this mass of the barium compound into the moles, and also this mass to be converted into the moles of barium sulfate. We need these two different moles because we cannot minus these two values from each other, because if we do so, we are basically reducing the amount of the barium dithionate, and that cannot be done because it involves two steps. So the first step involves the solubility of the barium dithionate, and the second step involves the reaction of S2O6 2 minus with acid. So basically, we require to have moles of two different compounds. So I'm going to find the moles of the compounds. For that purpose, I need to clear all this writing. So first of all, let's calculate the MR value for the barium dithionate compound. So MR of this compound is calculated as we have one barium ion, we have two sulfur, and then we have 8 oxygen and 4 hydrogen. So value is something like this: 137.3 plus 32.1 times 2. I will use the formula for my calculation. I'm just going to add O6 after this. 16 times 6 plus, for water we have 18 times 2. The answer will be equal to 333.5 gram per mole. So this is the MR value of this compound. Now we will calculate the moles of this barium compound, moles of BaS2O6. I'm not writing the full formula, but it's clear. The answer can be calculated as the mass is provided here, 3.153 gram, divided by the value which we have calculated, 333.5. When you do the calculation, you will get the answer equivalent to 0.010, 0.010, 5337. It is still not all the digits, so you can see the answer in your calculator. Now the next part is to calculate the moles of the barium sulfate, because this 0.661 gram belongs to barium sulfate. So I'm going to write that. Number of moles of barium sulfate. For the, first of all, you should also remember the MR value for barium sulfate. It is equivalent to 32.1 plus 137.3 plus 16 times 4. And then we have the 233.4 as a MR value, 233.4 gram per mole. Now calculate the moles. We have 0.661 divided by 233.4. Now the answer for this part is equal to 0.00 0.002 8320 48. Now this is the mole for the barium sulfate. Now, according to the theory, it says that this much mass was present in the form of precipitate. So the thing is that we have to minus that mole from the barium compound. So dissolved moles of barium compound, that is barium dithionate, PaS2O6 or 2H2O, will be equivalent to 0.0, the value from here, 0.010 5337 minus 0.002, the value from the barium sulfate, 283204. This answer will be equivalent to 0.0007716. So this is the mole of the barium compound that has been dissolved. Now we just need to use this formula to convert into concentration. The value for the volume comes from here. It is equivalent to 100 cm cube, and we need answer in dm cube. So it is equal to 0.1 dm cube. So simply use that value in the formula. So mole be 0.0077016 divided by 0.1, and the answer will be equal to 0.077. And this answer is equivalent to the option C. C is the correct answer. Now, next question, number 13. It says the diagram shows two containers of methane connected by a close tab. We have this diagram of two containers, and then the methane is present in both the containers. The tab is later on opened and the temperature is changed to 800 Kelvin. The system also reaches to a constant pressure. We have to determine that pressure value. So basically, we cannot use the pressure before the tap was opened, because the temperature has been given the value after the tap was opened. We need to use the formula PV is equal to nRT over here to determine the pressure value when the tap was opened. So when tap was opened, the volume has been changed from 1 meter cube into 2 times, because we know but both sides have 1 meter cube volume. So this will be equal to 2 meter cube. And since the pressure is given in kilopascal, so that means we need to convert this meter cube into dm cube. And we know 1 meter cube is equal to 1000 dm cube. That means it will be equal to 2 times of the 1000. It is equal to 2000 dm cube. We remember the relation between pressure and volume. If pressure is in Pascal, then volume is in meter cube. When pressure is in kilopascal, the volume is in dm cube. Okay, now we have calculated the volume of the tap was open. We know the temperature, that's already in Kelvin. We need to see the number of moles. Now, moles is for the methane. Methane formula is CH4. The MR value is 16 gram per mole for CH4. Now, we also see the mass of the methane on both sides, 16 gram on the left container, 96 gram on the right container. So, mass after opening the tap is equal to 96 plus 16, that is equal to 112 gram. 112 gram after opening the tap. We need to convert it into the moles. So mole will be equivalent to 112 divided by 16. It is equivalent to 7 mole. We have also got the value of mole. Now we simply need to convert this formula of P is equal to nRT into the pressure. It will be equal to pressure, it will then be equal to nRT over V. So by putting the values, P is equivalent to moles has been calculated to be 7 mole into R is general gas constant, value is 8.31, and temperature is 800 divided by the value of volume, that is calculated to be 2000 dm cube. So when you do the calculation, you get the answer equivalent to 23.268 kilopascal, which is equivalent to 23.3. So that's why the correct option becomes A option. Now the next question, number 14. Which statement about 3p orbital is correct? It can hold a maximum of 6 electrons. Now it says about 3p orbital, that means it could be px, py, or pz. But statement A says it can hold a maximum of 6 electrons. So 6 electrons are present in p subshell, not in p orbital. That has to be recalled. That p subshell contains 6 electrons, not the p orbital. So that's why A is incorrect. B says it has a highest energy of the principal content number 3. So that's wrong, because in the content number 3, we do also have 3s subshell. And 3s has smaller in energy than 3p. So that's why this is wrong. Then the next one, it is at a higher energy level than the 3s orbital, but has the same shape. So that's wrong, because 3s orbital has a spherical shape. On the other hand, the p subshell has, the p orbital or p subshell has a dumbbell shape. It has a dumbbell shape. So that's also wrong. They do not have the same shape, they are different. D says it is occupied by 1 electron in an isolated phosphorus atom. Now, isolated phosphorus atom, we should remember it is present in group number 5 of the group of the periodic table. That means it has 5 valence electron. The electronic configuration for the 5 electrons is written as 3s2 and 3p3. Now, there are 3 electrons in p subshell, but if we elaborate this 3p into its respective orbitals, we will write like this: 3px, 3py, 3pz. Now they are 1 electron each in these orbitals. Now we see that all the 3 orbitals of p subshell occupy 1 electron each. There is one electron in each p orbital, so that is a correct statement according to the given option. So D is a correct answer. Now the question number 15, it says, in which pair do both species have the same shape and same number of covalent bonds? So we need to remember the formulas. in order to get the right answer. The carbon dioxide has this shape and this formula. It contains a linear shape, and nitrogen, on the other hand, has a nitrogen triple covalent bond with another nitrogen atom. It's also linear. Both are linear, but with respect to the number of covalent bonds, it has 4 covalent bonds, and this one has 3 covalent bonds. Now, boron trifluoride, BF3, which is boron bonded with 3 fluorine atoms. There are 3 covalent bonds, and the shape is trigonal planar. It's trigonal planar, and ammonia, on the other hand, having this type of the bonding. So the shape is trigonal pyramidal. It's trigonal pyramidal. So that's wrong. They do not have same shape. Water has a bent shape, and oxygen has a linear shape. So they don't have same shape. Now let's talk about methane and ammonia. Methane is CH4. So we have tetrahedral shape for methane, and also for ammoniamine, which is NH4 positive 1. We have similar type of the shape. And the whole compound present within the bracket with +1 charge. There are equal number of covalent bonds, which are 4 in each, 4 bonds in methane and 4 bonds in ammoniamine. So shape are same, tetrahedral in both cases, and the bonds are also same. So A is the correct answer. Now, next question number 16. It says a reaction involving ammonium ion is shown. We have to select the correct answer. The first statement says ammonium ions are reduced. So basically, if we look at here, when ammonium ion is compared with the ammonia, it has lost hydrogen ion. That is basically a definition of oxidation, loss of hydrogen ion. So that's not, so it's not reduced, rather it's oxidized. So that's incorrect. 2 says in the reverse reaction, ammonia acts as a bonded Lowry base. Reverse reaction means when you have to move from right to left. This is the reverse reaction. So ammonia acts as a base. So yes, we can see that the water has donated the proton to the ammonia. That's why H2O has been converted into the OH negative. So it has, water has worked as a base. Water has worked as an acid because it has donated the proton. It has donated the proton to the ammonia. The water becomes an acid. In other words, ammonia has accepted the proton, so that's why ammonia becomes a base, Lowry bronzed base. So 2 is the correct option. 3 says the ammonium ion and the ammonium molecule has the same bond angle. So if we look at here, and within the NH4, it's a tetrahedral shape, as already mentioned in the previous example. We already have an example NH4 in the previous question. The angle was in tetrahedral 109.5 degree. Whereas in case of ammonia, also present in the previous example, ammonia is basically having 107 degree. In ammonia, there is 107 degree. So they are not same bond angles. So 3 is incorrect. The 4th is the reaction is not a redox reaction. So that is correct because in all the cases, nitrogen will have -3 charge, -3 charge. Hydrogen will have +1 charge in all the atoms of compounds, and oxygen will have -2 charge in all the cases. So it's not a redox reaction. That is also correct. That means the C is a correct answer, having options 2 and 4 correct. Question number 17, sorry. It says which reduction process occurs on the surface of a catalytic converter? So what we see in this question, which reduction process occurs on the surface of catalytic converter? So basically, if you remember, so reduction of carbon dioxide and nitrogen oxide, basically, we remember that carbon monoxide used to convert into the carbon dioxide. Now they basically the gain of oxygen, and gain of oxygen means it's oxidation reaction, not reduction. And also for nitrogen oxides, they convert into the nitrogen molecule. Similarly, for NOx, converting into the nitrogen is in this case, this is not oxidation, rather it's a reduction, because we can see there is loss of oxygen. There is loss of oxygen. So this part is correct, that there is a reduction of nitrogen oxides, but the second part is incorrect because there is oxidation. There is basically conversion from carbon monoxide into carbon dioxide, not the inverse process. So this is totally wrong. We basically convert carbon monoxide into the carbon dioxide. And then the B option says reduction of carbon dioxide only. So now that's also not possible, because we convert carbon monoxide into the carbon dioxide, and that is the oxidation process. So this is not correct. Then C says reduction of nitrogen oxides only. That has already been explained here. So that is yes. That includes a reduction of nitrogen oxides, and the D says reduction of carbon monoxide. So no, carbon monoxide converts into carbon dioxide through oxidation, already stated before. So it's not reduction, rather it's oxidation process. So D is also wrong. So the only correct option is the C option, that is the reduction of nitrogen oxides into nitrogen. Now question number 18, with three statements about halogens, chlorine, bromine, and iodine, and their compounds are listed, we have to select the correct statement. So the first statement says the halogen with the highest bonding point has atom which form the strongest bond to hydrogen. So if we remember the position of the halogen elements in the group, it is chlorine at the top, then chlorine, then bromine, and then iodine. So the one with the highest bonding point is at the bottom. This one has highest boiling point, iodine, and it forms the strongest bond to hydrogen. So no, that's wrong. It forms the weakest bond. Because of the increased size of the element, the bond length becomes longer and the bond strength becomes weaker. That's indirect relation. Bond length is inversely proportional to bond strength or bond energy. Bond energy or bond strength. So it is inversely proportional. So iodine makes the weakest bond with the hydrogen. So one becomes wrong. Second statement, the halogen with the strongest instantaneous dipole ideally interaction form the most thermally stable hydrogen halide. So again, iodine has the highest or strongest IgD forces, being with the largest size and having most number of electrons. And it says most stable, most thermally stable hydrogen halide. That means that hydrogen to iodine bond should be very strong. So that's wrong. It's the weakest bond. So if it is weakest, then thermally it is unstable. So that's why we would say it is unstable bond, thermally very unstable bond. So that's again wrong. Third, say the most volatile element most rapidly oxidizes hydrogen. So chlorine is gas. Chlorine is a gas. So we know that chlorine is most the most volatile, and at the same time it rapidly oxidizes the hydrogen, because we know the order of reactivity of halogen is something like this. Fluorine is more oxidizing agent than chlorine, which is more oxidizing than bromine, more oxidizing than iodine. So fluorine being the most strongest oxidizing agent, it will easily oxidize hydrogen to make HF. And within HF molecule, hydrogen has sigma positive charge on it and fluorine has sigma negative charge on it. So it has oxidizes the hydrogen. So only the third statement is the correct one. That means the correct option becomes D. Now question number 19. Which reagent and condition will oxidize chlorine into compound containing chlorine the +5 oxidation state? So if you remember the equations between the cold dilute NaOH with chlorine, we had Cl2 plus NaOH to make NaCl plus NaOCl, or you could say NaClO. Both mean the same thing, NaClO plus water. In this case, the oxidation state of chlorine was +1, because the oxygen had -2 and sodium has also +1. And in the other case, when it reacted with concentrated hot concentrated NaOH, was Cl2 plus NaOH, and that produced a NaCl, similarly like the cold NaOH, plus NaClO3. Now in this case, along with water, the state of chlorine was +5, because oxygen will cumulatively give you -6. -2 times 3 is -6, and that of sodium is +5, +1. So that's +5 on the chlorine in that case. So that's why the correct option becomes the D option. Now, question number 20. Which diagram shows the electronegativity of the elements plotted against ionization energy? Now, we need to recall the trend of the electronegativity. So, moving from left, and all the elements are of the period number 3. These are period 3 elements. So, we will just discuss the trend across a period. So, moving across a period from left to right, electronegativity value increases. And with respect to ionization energy, then if we remember, generally speaking, from left to right, generally, first ionization energy, since they are asking for first ionization energy, the first ionization energy generally increases, but specifically speaking, the third ionization energy or the element of group third had, we could say the group third ionization energy was less than second ionization energy of group second, and also the ionization energy of group 6 was less than the ionization energy of group 5. These were the exceptions in terms of the first ionization energy. So we have to include that factor here. So first let's look at option C, that says the electronegativity is increasing, not in that order, because y-axis indicates the electronegative. So it should be something increasing across a period. So we see that sodium has greater than magnesium, and then magnesium has smaller than aluminum. So magnesium is smaller than both sodium and aluminum. That's wrong. So it's a incorrect option with respect to electronegativity. And also in option D, we again see the same trend that it is decreasing from sodium to aluminum. That's totally incorrect with respect to electronegativity. Both option A and option B both have an increasing trend of the electronegativity across a period, but we need to look at the trend of the first ionization energy. So as we said that group 3 has smaller ionization energy than group 2, we can see here that the magnesium has higher ionization energy than aluminum. Magnesium belongs to group 2 and aluminum belongs to group 3. So yes, group 3 has smaller ionization energy than group 2. So that's why the correct option becomes option B. Now then question number 21. Now in this question, radium is an element below barium in group 2 of the periodic table. Which equation shows what happens when solid radium nitrate is heated strongly? So basically in this case, we have to remember how the group 2 compound, the group 2 nitrate compound used to decompose upon heating. So basically we remember that whenever the group 2 nitrate decomposes, it produces the metal oxides plus nitrogen dioxide plus oxygen gas. So if you look at here, this is the correct formula of the metal oxide. And among the nitrogen oxide, we have this one as the correct formula. And the other last product is the oxygen. So that's why the correct option becomes A option. Now, our next question, number 22. In question number 22, we are provided with a table and we have the options below. We have to correctly check the statement from the given table. So if we look at the table and match the information, it says that all the elements in the table with a giant structure have a higher melting point than each of the elements in the table with a simple molecular structure. So basically, if we look at the table, we can see that sodium has a giant structure. It has a giant structure. And its melting point is 371. On the other hand, sulfur is a simple structure, but its melting point is 386, which is greater than that of sodium. So we would say that melting point of P4 is greater than, it's sulfur. Melting point of the sulfur acid is greater than the melting point of the sodium, even though acid is a simple molecular. So we cannot say that all the elements in the table have higher melting point with a giant structure, because sodium is a higher giant structure, but its melting point is smaller. Then we look at the statement 2. Magnesium has a higher melting point than sodium because it has more delocalized electrons and stronger electrostatic attraction. So according to this statement, it is correct, because we know that magnesium has +2 charge on it. On the other hand, we have to compare with the sodium. Sodium has +1 charge on it. So being +2, it has 2 electrons lost by each sodium cation. So each metal cation. On the other hand, each sodium has lost 1 electron. So there will be greater attractive force between +2 charges and 2 electrons provided by each magnesium. So statement 2 is correct. Then statement 3 says phosphorus and sulfur do not conduct electricity because they are simple molecular solid at room temperature. So we do remember that all these simple molecular solids did not have any delocalized electrons or any cations or any free ions. We would say any free ions. They do not have free ions, they do not have delocalized electrons. That's why they could not conduct electricity. So statement second and third both are correct. That means the correct option becomes the D option. Now the next question, number 23. In question 3, it says each mineral listed behaves as a mixture of two carbonate compounds. They can be used as fire retardants because they decompose in the heat, producing carbon dioxide. And this gas smothers the fire. So we have the carbonates of these compounds. We have to tell what is the order of the effectiveness as fire retardant from best to worst. So basically, we need to understand regarding this question that which compound will easily be decomposed to produce the carbon dioxide. So this is the order of the elements in the group, second group. We have the magnesium, then calcium, strontium, and then barium. And while moving down the group, thermal stability increases for the carbonates of these elements. That means it is easier to break the magnesium carbonate as compared to the barium carbonate. So if we rank these elements with respect to the carbonates, I would say that magnesium has the highest priority, or you could say it is easiest to thermally decompose, and barium has hardest property to decompose. So that's why I'm numbering these according to ranks. So barium has the weak hardest or lowest value. Now I'm going to assign these numbers to the compounds present in the given options. The barito side will have one barium. So I'm writing 1 for barium, and calcium is assigned number 3. So 1 plus 3. And for dolomite, I have calcium and magnesium. Calcium is assigned number 3. Magnesium is assigned number 4. 3 plus 4 gives, so I will add that values as well. Now in huntite, there are 3 magnesium atoms. So 4 times 3 plus I have calcium as well. So 3. Now add these values. This is 4, this is 7, and this is 15. That means it is easiest to break down the huntite compound, and it will be working as a best uh, fire retardant. The best fire retardant is the huntite because it has those elements which are more easier to be decomposed upon heating. So huntite is the best. So I'm putting ticks in front of huntite as the best. And the worst is the one which has the lowest value, that is barytosite. So barytosite has a worst. And I can see that dolomite is in between. So dolomite is here. So there are now 3 ticks across a D option. So that's why D is a correct answer. Now, question number 24. Compound X contains 2 period 3 elements, Y and Z. Compound X reacts with water to form only 2 products, slightly soluble hydroxide and compound Q, and then It also says that Q has element Z and hydrogen. Q burns in moisture to produce oxide water, but the oxidation number Z is +5. We have to identify the identity of the two elements present in compound X. All right, now starting from the identification from the given statements, the compound X reacts with water from only two products, a slightly soluble hydroxide and compound Q. Now the given options includes metallic side as element Y. So if we look at the soluble hydroxide, that it can only include the sodium hydroxide versus magnesium hydroxide. Now if we remember the solubility trend of the group 2 hydroxide, we remember that moving down the group, the now in this question, uh, we have just decided that going down the group, solubility of the hydroxide decreases. So we could say solubility decreases. That means, my mistake, solubility increases, not decreases, rather it increases. While moving down the group, solubility increases. That means if we look at here, magnesium is present at the, we know it's present just below the beryllium, and so by that, we can say that magnesium will be having low solubility, and we have only two elements present. So magnesium is the one having less solubility in its group. One more thing, as we go across the period, then the solubility decreases for the hydroxides because there is greater charges present on the group 2 element. We know that on a group 2 element we have +2 charge, so they have greater forces with the hydroxide ion. On the other hand, the sodium having +1 charge on it, it will have less attractive forces with the hydroxide, and as a result of this, sodium hydroxide can be dissolved more easily. So being present on the top, almost on the top of the group, the magnesium has less solubility in its hydroxide form. So we can judge from here that the element Y will be magnesium. Now that is identified. Now we move on to the next part that says Q is a compound. Q is a compound in which we have the element Z, and element Z will be the other element that we have to identify. So from here, it says that it forms the oxide when burns in moisture, and that oxide has +5 state on it. Now, within the element Z side, we know that there are only two elements present, phosphorus and sulfur. Phosphorus is in present group 5, and if we say it makes the oxide form, so being in group 5, it will have 5 electrons. That means it will lose all the 5 electrons to have +5 charge on it. On the other hand, sulfur is present in group number 6. When it loses all of its 6 electrons, it will have +6 charge on it. And we also know that phosphorus can also make oxide with oxygen, in which it will have +5 oxidation state, which is in this case P2O5. So this is the compound of the phosphorus that will be formed when it reacts with moist air. So phosphorus is the correct answer from the column of element Z, and in this way the correct option becomes A option. Now question number 25. three reagents are listed. These three we have to react. We have to check that which of these three, when reacted with the pure ethanoic acid, will give a solution containing ethanoate ions. So this is sodium carbonate. Now reaction of sodium carbonate with ethanoic acid is something like this: Na2CO3 plus ethanoic acid CH3COOH. It shall produce CH3COONA plus carbon dioxide plus water. Now in this CH3COONA, we have this ethanoate ion present. COO negative. When it is dissolved in water, it will produce CH3COO negative. This is the ethanoate ions plus Na positive. Now, if we react lithium aluminum hydride with ethanoic acid, it shall reduce it, and it will reduce it to ethanol. Firstly, it will reduce it to ethanol, and that will be CH3CHO, and this is ethanol, and then further into ethanol. So it does not contain any ethanoate ions. And when water reacts with ethanoic acid, it is something like dissociation. So within the water, it's at a pure ethanoic acid. So it is something like being dissociated in water to make CH3, COO negative, and hydrogen ions. And that hydrogen ions are accepted by the water. So we can also write it as H3O positive. So we have ethanoate ions present in the third reagent and also in the first reagent over here. So in this way, the option B is the correct option, containing both statement 1 and 3. Now the next question, number 26, states complete combustion of compound T produces carbon dioxide and water. Compound T produces steamy fume with PCl5. And compound T does not give any visible product with 2,4-dinitrophenylhydrazine. What can be deduced with certainty from this information? So basically, here in this compound, we need to match the possible information. It says that compound T produces carbon dioxide and water only. I will say this is statement 1. And then the second statement says it produces steamy fumes with PCl5. This is statement 2. And the third statement is it does not give any visible product with 2,4-DNPH. This is third statement. I will apply these statements on A, B, C, D. So statement and the option A says compound T is a carboxylic acid. So basically, instead I will say that compound A, B. I will apply all these three statements on all the options. So compound option A says carboxylic acid, B says hydrocarbon, C says it's alcohol, and D say it's aldehyde. So basically, all these statements hold all these options hold the statement 1. Or in other words, I would say the statement A is the statement 1 is applied on all the options A, B, C, D, because all of these compounds produce carbon dioxide and water upon complete combustion. So we have all the 4 options according to statement 1. Then according to statement 2, it says it produces steamy fumes with PCl5. So about that, we can say that the alcohol produces the statement. This is statement 1, this is statement 2. The alcohol produces the steamy fumes with the PCl5. And then no other compound produces the steamy fume with PCl5. And then The third statement says it does not give any visible product with 2,4-dinitrophenol hydrazine. So basically, the third statement also applies on alcohol because it does not provide any product with the 2,4-dinitrophenol hydrazine, and also the aldehyde also does not provide the we could say it says not an aldehyde. If it was the aldehyde, then that statement would have been corrected. But it says compound T is not an aldehyde because it does not give. So that's why the third statement also applies on option D. And moreover, the steamy fumes, as we know that steamy fumes is only provided by the alcohol. So this statement, we can say the aldehyde, it's not an aldehyde. It means it could also be alcohol, it could be hydrocarbon, it could be carboxylic acid. But then we need to understand that alcohol does not uh, react with a 2,4-DNPH, and also the not an aldehyde means the same thing, that in a sense it could be any other compound. It could be alcohol, it could be hydrocarbon, carboxylic acid. So we can say that it is definitely not A, because carboxylic acid does not give any steamy film with PCl5, and it does not react with the hydro 2,4-DNPH. And also B is not the correct answer because it also does not react with the PCl5 and it does not react with the 2,4-DNPH. Now C cannot react with 2,4-DNPH, and D is not an aldehyde. So we need to understand what shall be the more certainty from this information. We can expect that if it does not react with, if it does not produce any visible product, then it's clearly indicated that it is not aldehyde. It's not aldehyde. That's why it could not react with the 2,4-DNPH. And in the previous statement too, it produces steamy fumes with PCl5. So that means it could be an alcohol. That could be an alcohol because it reacts with the PCl5, but it is certainly not the aldehyde. It is an alcohol, but it is certainly not an aldehyde. So just by looking at the reaction of 2,4-DNPH, we can say it's not an aldehyde. So that's why the correct option becomes the D option, even though it's very confusing answers. Like we can say that both C and D can be said to be correct answer for this question, but the more weightage is given to the last statement, that is third statement, in which it does not give any visible product with 2,4-DNPH. That means we can say alcohol also does not react with 2,4-DNPH, and that there are no other product there. Now question number 27. Information about carbonyl compound X is given. We have X reacting with the lithium aluminum hydride to produce secondary alcohol. Now, if it is the carbonyl that produces secondary alcohol, then it is clearly indicated to be a ketonic compound. It's a ketone. And the second point says it reacts with alkaline I2 to give yellow PPT. That means it's a tri-iodoform test, tri-iodoform reaction. So for that case, the compound must have CH3 C double bond O group. It must be there in the carbonyl compound. Now, from the two statement, we can clearly say that it's not a butanol because it's not a ketone. C is also not a ketone. Now, between B and D, we can say that structure of D is something like this. I'm just writing simple structure. There are 5 carbon atoms with the position of carbonyl group on the position number 3. Now here it does not match with this part. This part gives the triiodoform test or yellow PPT test. And if we check the structure of the butanon, it is something like this. We have the double bond carbonyl group on the second carbon. Now here we do have the same part that is required for the triiodoform test that resemble with this part. So from this we can say it's the option B, that's the correct answer. Now we have the next question number 28. In question 28 says an organic compound J react with excess of sodium to produce an organic ion with a charge -3 and then react with NaOH to produce an organic ion with charge -1. We have to identify the correct compound. So we should remember that in these compounds we have different types of the functional groups present. The reaction with the sodium is given by the alcohol and then by the carboxylic acid. So we have to look at those compounds which will react with the metal, and we remember when it reacts, let's suppose if I say it is a carboxylic acid that is reacting with the sodium, then it will produce RCOONA, and this compound basically exists as negative ion along with the plus charge. So this is the ion they are referring to. An ion, an organic ion with -1 charge. This is the ion we have to look for it. So as we said that both alcohols and carboxylic acid react, so it should be having such groups. We should have at least 3 groups that must be reacting with a sodium metal to give a -3 charge. So we should have 3 different functional groups. We should have 3 groups in total, and that can include alcohol and carboxylic acid. So we have OH, and then another OH, and then carboxylic acid. So these 3 functional groups will be reacting with the metal, sodium, from option A. Then in option B, this is the carboxylic group, alcohol group. These 2 will be reacting. This is the aldehyde group. This part is aldehyde and it does not react with the sodium metal. So it is excluded. So B is not the correct option. Then in option C, we have again carboxylic acid group, alcohol group, and carboxylic acid. 3 groups are there. And then D, we have the alcohol group here. And this one is a ketone group. This one is ketone, so it does not give the product. And this is aldehyde, it also does not give the product. So that's also excluded. Now we are left with 2 options, A and C. Now we will look for the second statement that says when it reacts with NaOH, it should give a charge of -1. That means there should be only one functional group that should give the product. So we will look for those groups in the option A and option C. In option A, one more thing, we have to see which compounds can react with the NaOH. So it is only the carboxylic acid that can react with the NaOH because it's a neutralization reaction between base or alkali with acid. So it's neutralization reaction. So in option A, we have one carboxylic group present. So it can give reaction with NaOH. On the other hand, neither the alcohol group or this side and this side will react. So there's only one part. And in option C, we have 2 carboxylic groups. That means the charge given by the compound C will be -2 charge, but we require -1 charge here. So -2 is not the correct answer. And option A gives -1 charge. That's the one we require. So that's why A is a correct option. Now, question number 29. Which formula represents the organic compound formed by the reaction of propanoic acid with methanol in the presence of concentrated sulfuric acid as a catalyst? So basically, this is the reaction to form the ester. So ester formation is something in which carboxylic acid reacts with alcohol to make an ester. We need to find the correct formula of the ester. So if we remember, the ester is represented like this: RCOO and then R prime. Or you could also represent it like this: RCO2 and then R prime. So basically in this case, we have R, then C, that is carbonyl group, and then one more oxygen through single covalent bond, and then R prime. So this part is basically the alcohol part, as you remember from the O levels, and this part comes from the carboxylic acid group. Now we have the propanoic acid that must be of 3 carbon atoms bonded through the carbonyl group, and the other part is methanol. That means it must be bonded through single bonded with oxygen. So it should be something like this: CH3O. Now we will find that structure here. Now in option A, we have the CO group present here only. That indicates the ketone group. So ketone is not our answer. It's not an ester, so A is incorrect. The B says it has 5 carbon atoms. So it we will in ester have 4 carbon, because 3 carbon atoms come from the propanoic acid, 1 carbon comes from the alcohol. So we should have 4 carbon in total. So D is also incorrect. Now we check B and C. Now between B and C, we have to see at the position of CO2. So CO2 is present here, in which we can see there are 3 carbon atoms, and these 3 carbon atoms belongs to the carboxylic acid, as indicated in this generalized formula, that these 3 carbon atoms belong to the carboxylic acid, and that means propanoic acid, and the right carbon belongs to the alcohol. And if you compare with the C option, then in C option we have the 2 carbon atoms that and then we have O2. That means these 2 carbon atoms come from the carboxylic acid, but that should indicate ethanoic acid, not the propanoic acid. So that's why this 2 carbon atom is not the correct option. So the only correct option becomes the B option. Now the next question, number 30. The question number 30 is the trickiest one in the organic chemistry, and this will definitely be included in the examiner report when it will be published, because it is yet not published on the Cambridge Sport website. So let's understand how this question will be explained. We have to understand that in the question, we have to understand the structural and stereoisomerism should be considered when answering this question. We have this compound, and it is reacted with the reflux under ethanolic KOH. We have to tell how many isomeric compounds will be formed with this molecular formula. So basically, it is a simple reaction between the haloalkene with that of ethanolic KOH, and we remember it gives the alkene as a product. So alkene is formed as a result of this reaction. So I'm going to draw the simple structure of this compound, 2,5-dibromohexane. In simple way, we have 6 carbon atoms, and then on position number 2 and 5, we have bromine atoms bonded. This is position number 2, let's suppose, and this is position number 5. Now when it reacts with a KOH in the presence of the ethanol, it gives the elimination reaction with the removal of the bromine along with the hydrogen. Now basically I'm gonna draw different colored hydrogen atoms here to make it easier to understand. from which point the hydrogens can be eliminated. We can understand this is a symmetrical molecule in which the hydrogen atoms are also present on the ends of the carbon atoms, and then the hydrogen atoms are present in the inside of the hydrogen that can also be removed, because it's not just the bromine that's going to be removed, but also the hydrogen atom. Now, basically, I will draw different isomers that will be formed from these combinations. So I will again draw different combinations of the product form. So here we have again backbone of 6 carbon atom and another structure over here, and another structure over here. Now, in all these cases, there will be 6 carbon atoms. So let's start from here. I'm going to remove the, I will draw with different color. I will remove the, definitely these bromines have to be removed at all cases. These will be removed. But along with these bromine, what else can we remove? We can remove the hydrogen atoms of the either ends. When the hydrogen atoms of the either ends will be removed, that means there will be double bond present over here and double bond present over here. So I'm going to label those double bonds here. One double bond will come over here and another double bond will come over here. This is one isomer form, because we remove the hydrogen of that was red label and the bromine atoms on both sides. Now in the second situation, I will now remove the red label hydrogen atoms in both the cases along with the bromine. So bromine will definitely be removed, but along with that we are going to remove the black label hydrogen. So I'm going to remove the black label hydrogens here. That means the double bond will come over here and another double bond will come over here. So in that case, the second structure that is drawn here, it will have double bond present over here and another double bond present over here. Now this is the second isomer. So this is the first isomer, this is the second structural, and mind it, these are the structural isomers that we are finding. Now I'm going to do a combination in a sense that in the third case, I will use one hydrogen that is labeled red and the other hydrogen that is labeled black. So basically, if you look at the structure carefully, it's a symmetrical molecule. So let's suppose if I remove one hydrogen that is labeled black and the other hydrogen that is labeled red, it will be similar to the other case if I remove the red label hydrogen of the right side and the black label hydrogen of the right side. So it will still give the same structure. So now, in which position would I have the double bonds coming on the structure? A double bond will come one over here. There will be one double bond present here and the other double bond, just to make sure I don't have to remove this hydrogen of the left side. I have to remove the hydrogen of the right side because bromine is present on the right side. So this is the hydrogen that I will remove. Now in that case, the double bond will come over here. So these are position number 1, at position number 1, and at position number 4. At position 1 and 4, we will have the double bonds present. So the first double bond will come at this position, carbon number 1, and the other double bond will come at position number 4, right over here. Now in this case, I have another isomer formed. This is my third structural isomer. All these three are basically the structural isomers only. I have not included any of the stereoisomer right now. No stereoisomer is yet decided. So the three structural isomers are formed as a result of these three different combination of removal of the elements from the three different compounds, from one single compound. Now, if you try to remove the hydrogen of this side along with the, I would say, the hydrogen of this side, it will give the same structure like this one because it will have similar positions of the double bonds. So it will be of no sense if you try to remove these arrow directed hydrogen atom. It will have the same structure like this one. Now, I'm going to indicate the structural isomers that will be, I'm going to indicate the stereoisomers that will be formed from these three different structural isomers. Now, stereoisomers includes two further types. We have the optical isomerism and we have the cis-trans isomerism. So, optical plus cis-trans or geometrical, both are the same thing. Now you have to apply the two type of the isomerism on all these three molecules. If you consider all the three molecules, you can see that there is not a single carbon atom on which there are four different groups attached, because that is the condition required to give the optical isomerism. That means the dextrorotatory and levorotatory isomers, but there are not a single carbon atom present in all the three molecules in which there are four different atoms or group of atoms attached. So that means optical isomerism is opted out from here. It's excluded. Now we will check the cis-trans. For cis-trans, we need the requirement of the double bond, and we can see here that all the three molecules have double bonds present. Now we have to find where the cis-trans isomer will exist. Now, if you look at the structure number 1, we can see that this carbon has two hydrogen atoms bonded on it. So, two hydrogen atoms when bonded on the carbon does not give cis-trans. Also, on this carbon, we have two hydrogen atoms. So, there is no cis-trans here. So, there is just one isomer form. I'm going to write that over here. There is one isomer. In total, I have only one isomer from here. One is giving only one. So that's only one. Then we check the second compound. Now in second compound, we can, to make it easier, we go for the third compound first to make it easier. In the third compound, there is similar situation that there are two hydrogen atoms present on this carbon. That means there is no cis-trans on this carbon. But if you look at this carbon, these two carbon atoms, we do have cis-trans situation, because the right carbon of the double bond has an alkyl group present over here, and similarly the left carbon of this double bond has this whole thing as the alkyl group present on it. So this is alkyl there are now two alkyl groups on these two carbon atoms. I need to remove this circle because I meant to say the right carbon of the double bond. So both the carbon atoms have alkyl groups bonded in. This is the three carbon atom alkyl group, and this is one carbon atom alkyl group. Now, along with that, both the carbon atoms have hydrogen atoms along with that. So hydrogen atom on this carbon and another hydrogen atom on this carbon. In this way, these two carbon atoms can give the cis-trans isomers. So we would say that the third isomer is split into two more, but we will consider only one more isomer, because the third isomer was basically having either the cis configuration or the trans configuration. So we cannot add two more isomers into the third structural isomer. We will only consider one more, because this compound could be either cis or it could be the trans that is already drawn before. Although I have not drawn in terms of the cis-trans, I just said this is the third structural isomer. So it could be the cis or it could be the trans. So if it is, let's suppose, then I will consider another isomer will be the trans. So as a result of this, I will say that I will add now two more isomers in this part. The first one was already mentioned in the first structure, and then there are two more isomers coming from the third isomer, because one is a cis and the other one is a trans. So 1 and 2, there are now total 3. Now we have to come to the compound 2, the second isomer. Now in second isomer, we have the situation in which you can see that a cis-trans can be obtained from these two carbon atoms. cis trans is coming from these two carbon atoms because we again have alkyl groups and the hydrogen atoms bonded on them. I can clearly show here. There is a hydrogen atom on this carbon, this hydrogen atom on this carbon, and this one is the alkyl group for the left carbon, and this whole is the alkyl group for the right carbon of the double bond. So in this way, we have cis trans coming from these two carbon atoms, and similarly, we have the cis trans in the right double bonded carbon atom as well. So cis trans is also coming from here as well. So what we will say that how will we calculate these number of combinations? So if we have a symmetrical diagram, this is a symmetrical, you have to learn this rule. If we have symmetrical structure for the double bonded compound, you should remember that we can have cis combination because of two double bonds, two double covalent bonds, cis combination. We can have cis trans combination. We can have trans combination, and we can have trans cis combination. Now, if you try to draw these structures, you will see that the cis and trans will have exactly same type of the compound. The structure will be the same for cis and trans. Similarly, if you draw these two, you will have similar positions of the double bond. You can tell these similar positions of the molecules on the basis of the position of the double bonds. They will have exactly same positions. Just like I said before, when we try to remove the one hydrogen labeled red and the other hydrogen labeled black, either from the one from the left and one from the right, or one from the right and one from the left, you will have same position of the double bond. Now, similarly, if you try to draw the structure having two double covalent bonds within the same structure, you have such a situation in which trans will be similar to cis and cis trans will be similar to trans cis. So that's why I will only consider one isomer coming from here and another isomer coming from here. So one each. So from the second compound, I will write that I have two more isomers from here, these two. Now, now the thing is that if I try to calculate total isomers, how would I tell? I would say that this is my first isomer, and without considering stereoisomer, this was my second isomer, and without considering stereoisomer, this was my third structural isomer. So three isomers are in total with respect to structural isomer, and then the second isomer was split into two more times. So 2 plus 2. The second isomer has two more isomers in it because we have we have included one isomer coming from here, one isomer coming from here. So 2 plus 2 gives me 4. So 4, these are in total. First, I had first, this is the second plus 2. So that means there are now 4 isomers. 4 isomers in total up to this point. And then this one was third isomer. That means 4 plus my third isomers. This I will write third because this is 4 isomers up to the compound second. And then 4 isomer plus third isomer, that gives me 5 isomers. And within that third isomer, I still had one more isomer coming from here. You can either take cis or the trans. That means the 5 isomers plus one more, that is equal to 6. So they are in total 6 isomers produced as a result of these different reactions. To make it clear again, this is my first isomer, this is my second isomer, this is my third isomer. So 3 isomers, 3 compounds, you could say. And then the second compound was split into 2 more isomers. So 3 plus 2, 5. And the third isomer was split into one more isomer, that is 1. So 5 plus 1, 6. So there are total 6 compounds that are formed as a result of this reaction. So that's why the correct option becomes the C option. Now, question number 31. Considering only structural isomer, what is the number of alcohols of each type with the formula C5H12O? Now, again, we have to draw as many isomers, and especially the structural isomer, to find out the exact number of the alcohols mentioned in these options. Now, this is the formula which we have to follow, and then we have to draw the isomers. Because the space is limited, I will draw the isomer right below here. Now, starting from a simple way, I have, let's suppose, a straight chain for the isomers. I have 5 carbon atoms, and then an OH is bonded with it. This will be the primary alcohol. Now, I'm going to use the same backbone of the carbon atoms to indicate the different combinations. Again, a straight chain, but this time the OH is mentioned on this carbon. That is carbon number 2. Another straight chain, and this time OH is present on carbon number 3. Now, from right to left, this is carbon number 2, this is carbon number 3. But if you move from left to right, it will give you the same position. If you try to put OH over here, it will be carbon number 2. And if you, again, this carbon will remain the 3, position number 3, even if you move from left to right or right to left. Okay, so we have now drawn 3 isomers. Now I will do some modification. Now this time I will put 1 carbon right over here. And this is my another combination of the carbons. Now I will put OH over here. This will be the primary. I will label these alcohols as primary, secondary, and tertiary after drawing different structures. Now another similar backbone of the carbon atoms, just like before. Now this time I will put OH over here. These are two different. These two are the different type of the isomers. They are not same, they are different isomers. And then another isomer of the similar carbon backbone. Now this time I will put, I have this position to place OH. This is another isomer. And then moving forward, similar backbone of the carbon atoms. Now, if I try to put OH over here or OH over here, they are same position. These are two same position in the compound. So I have option whether to put OH over here or OH over here. So I'm going to put OH on this carbon. It will be similar to attaching OH on this carbon. Now I have this as another part. This is the other variation in the isomer. Now the last one is that if I have this combination of the carbon atoms, now in this combination I have only one position to put OH. That means all these 4 carbon atoms have equal position. They are, in sense, they are equal positions in the structure. So if you put OH over here or OH over here or here or here, they all have equal positions. So it's just giving us only one point where I can put OH. Okay, this is the only way I could put OH for this type of the combination of carbon atom. Now I'm going to label these positions. So this is my, since it is attached on only one carbon atom, the OH is attached to that carbon atom which is attached with with only one more carbon atom. This is called primary alcohol. This carbon is basically attached with only one more carbon atom of this alkyl chain. So that's why it is called primary, represented by I naught. A similar primary alcohol can be seen over here. In this case, OH is bonded with a carbon. That carbon is further bonded with one more carbon atom. So that's why it is also a primary alcohol. Another primary alcohol is over here, in which the carbon which is tied with OH is attached with only one more carbon atom directly. It is not tied with 3 carbon atom or 4, it is attached with only one carbon atom. So it is also a primary alcohol. Now another primary alcohol is over here. You can see this carbon is bonded with OH, which is bonded with one more carbon atom. So it is also primary alcohol. So these were the only primary alcohols out of these isomers. Now we'll look for the secondary alcohol. The secondary alcohol is right over here, in which you can see the carbon is bonded with OH, which is bonded with 2 more carbon atoms, one from the right side and one from the left side. So this is a secondary alcohol. Now another secondary alcohol is this one, in which this carbon is bonded with 2 more carbon atoms, which has the OH group on it. So secondary alcohol over here. Then this one is secondary alcohol because this carbon is bonded with 2 more carbon atoms. So this is secondary alcohol. And then there is no other secondary alcohol. And then this one, the last one, it has the OH that is bonded with that carbon, which is bonded with 3 more carbon atoms. This carbon bonded with 3 more carbon atoms, so that's why I will designate as a tertiary alcohol. So this is tertiary alcohol. Now you can count how many tertiary alcohols are there. There is just one tertiary alcohol. So I will write here, tertiary alcohol is 1. And the secondary alcohol, how many there are? 1, 2, and 3. There are 3 secondary alcohols. And the primary alcohol, if you count from here, 1, 2, 3, and 4. So they are 4 primary alcohol. Now let's go back to the options. The tertiary alcohol was 1. There was only one tertiary alcohol. And with respect to primary alcohol, we had 4 primary alcohols. So 4 from here. And with respect to secondary alcohol, we had 3. So 3 is here. So the only correct option is the C option, having 3 ticks. Now the next question, number 32, which structure represents part of the polymer chain of PVC? Okay, if you remember from your literature, PVC had chloroethene compound monomer in it. Chloroethene is represented as CH2 double bonded CHCl. This is chloroethene. Now from this chloroethene, we make the PVC. That means if you expand this formula, it will look like this: CHH, then double bonded C, and then H and Cl. Now when you combine this similar monomer with the other monomer, that will have something like this. Now if you have to connect these two, you have to remove these double bonds from these two carbon atoms and replace them with a single bond, and then extended or dangling bonds on the either sides. You could have a combination like this, or you could have another combination in which the CH2 double bonded, I will show in the display formula, in which, let's suppose this H H over here, then CHCl, and the other monomer has the opposite side here. Instead of the chlorine, I will say the other side. Let me redraw the structure in which the Cl is on the left side, like this, and then carbon with two hydrogen atoms above and below. And then the other monomer has similar opposite side of the hydrogen atoms, like this, and then it has CH and Cl. Now, in this case, if you try to connect these two with each other, there should be at least only two carbon atoms having only the hydrogen atoms on them. So these are the two possibilities by which we can have the PVC. Now, if you check the option B, then option B has chlorine atoms connected on every carbon atom. Now, that is not possible because the chlorine atoms can only come on alternative position. This carbon has chlorine, and after skipping this carbon, the other chlorine comes on that carbon. So there is an alternative position for the chlorine. So the B option is opted out. Then we check the option number D. It again shows the same thing, that chlorine atoms are present on every carbon atom, so it is also wrong. Then option C indicate that there are three carbon atoms on which there are only hydrogen atoms. But according to this combination of the monomers, we should have only two carbon atoms on which there shall be hydrogens only, not three carbon atoms. So that's why this part is wrong here. That's wrong, so C is wrong. Now, if you look at option A, it says they are chlorine on the alternative positions of the carbon atoms. So that's the correct option. That's why A is a correct answer. Now, question number 33. A possible mechanism for the exothermic hydrolysis of this compound is shown along with the pathway diagram for the mechanism. We have to consider the correct diagram for this reaction. Now, for this purpose, if you remember the theory behind this, I will be showing the graph for this theory from my ES lecture notes. These are my ES lecture notes, in which you can see that this type of the graph is apparent whenever you have the tertiary haloalkane giving the SN1 reaction. So reaction profile for SN1 reaction is shown here. We see that the reaction goes through this high activation energy. Firstly, that involves the slow reaction, as we know that the slow reaction in SN1 is shown here. The slow reaction, which involves a bond breaking between carbon to halogen atom bond, and then it follows a fast step in which the two opposite ions are bonding with each other, and this is a fast reaction. Now, that can be represented in the reaction pathway diagram, in which the first step involves a very high activation energy because it involves a bond breaking between the carbon and the halogen bond, and then this is the intermediate stage produced. And when these two combine with each other, it goes through comparatively smaller activation energy. The activation energy is comparatively smaller here as compared to the previous peak. This peak has smaller activation energy, and after going through, it produces the product. You can see that there are two different curves. The lower curve is for the reaction in the presence of the catalyst, and the higher curve is representing the reaction without the catalyst. Otherwise, this graph belongs to the SN1 mechanism in which the tertiary haloalkane is used, represented by this letter, tertiary haloalkane. 3 naught means tertiary haloalkane. Now we come back to the question and we will see how we can resemble that graph over here. Now, the compound provided to us is 2-chloro-2-methylpropane. Now, this 2-chloro-2-methylpropane has this structure, and this is a tertiary haloalkane. It goes through first step, that is the slow step, and then it is going to the second step, that is the fast step, involving the combination of the ions. That means it must go through similar type of the graph. It must have two peaks, and that the first peak must have the higher energy. So among the options given, you can see that the B option has the first peak to be of higher activation energy, and then the second peak is of comparatively lower activation energy. It cannot be C because in C option, the first peak is of smaller activation energy and the second peak is of higher activation energy. So that's why the correct option becomes the A option. Students, if you require these notes for your revision in the PDF form, you can let me know. You can reach me out in the comment section. You can reach me out on the WhatsApp number or Instagram, and I can provide you the complete AS notes of the whole syllabus. You can see the page number over here. These are the actual page numbers, and I have complete AS revision notes. Along with that, I can also provide topical worksheets and the recorded lessons on a large interactive screen inside the classroom. Now, coming back to the question paper. The other question number 34, compound W contains atoms of carbon, nitrogen, and hydrogen. Compound W reacts with acid to produce propanoic acid, which row is correct? Now, again, we will look at the literature for the reaction between the compound W with acid to make propanoic acid. So if you remember, we have two options given, the amine and the nitrile. The amine is represented as RNH2. This is the amine group. And the other one is nitrile, that is represented as RC triple bonded N. This is the nitrile group. So we remember that whenever the nitrile is reacted with the acid, that could be HCl, that could be sulfuric acid, whatsoever, it will convert that nitrile part into the carboxylic group. So R will then be, this nitrile group will be converted into RCOOH. This is a reaction whenever the nitrile is reacted with the HCl. So this is the right answer from the first column. The nitrile is the right functional group from the first column. Now we have to decide which nitrile is used to make the propanoic acid. So within the propanoic acid, we have 3 carbon atoms, and the third carbon is bonded with the OH group, COOH group. This is the third carbon. It's a part of the functional group. That means the initial reactant, which must be converted into the propanoic acid, must have 2 carbon atoms present in it. So the 2 carbon atoms, it is named like this. If we have this type of the compound, or in other words, I would write like this. This is called as ethane nitrile. Now this CN will then be converted into COOH, which means there are 2 carbon atoms before that, and the name of such compound is ethane nitrile. That means this is the compound which will be producing the propanoic acid. You are converting this compound into the propanoic acid. So the actual answer is ethane nitrile. So that's why the correct option becomes the B option. Now question number 35, it states two reactions are described. We have these two reactions between these two compounds. In both reactions, the conditions are same and NaOH is in excess. We have this mass of the first compound to form 12.32 gram of product X. And then MR values both the compounds are provided. We have to check which row is correct. First of all, let's look at the second column. Let's say relative rate of the reaction. 1 is faster than 2 or 2 is faster than 1. 1 is the reaction between 2-bromo 2-methylbutane with NaOH, and second was 2-chloro 2-methylbutane with NaOH. Now, basically, if we remember, these reactions are indicating the hydrolysis of the compound, especially hydrolysis of the halogen compounds. And that means it is the nucleophilic substitution reaction. These are nucleophilic substitution reactions, in which we remember that the bond between the R and halogen is broken and it converts into R with OH group to make the alcohol. So basically, in the first case, it has to break down the C bonded with the bromine. And in the second case, it has to break the C bonded with chlorine. Now, which of these two reactions are easily broken? That will tell the faster rate of reaction. So if the reaction is faster, it means the bond is more easily broken. The faster reaction indicates easy bond breaking, or in other words, if the rate of a reaction is slower, that means the bonds are not easily broken. They are difficult to break. So between CBr versus CCl bond, we should remember that it is related to the bond strength and the bond length. We remember that bond length is inversely proportional to the bond energy, or you could say bond strength. So the bond between carbon to bromine is having bond length greater. The bond length is larger in this case because the size of the bromine is greater. The bromine size is greater than the chlorine. That's why the CBr bond is larger or longer, and that's why the bond energy is less in the CBr as compared to CCl. And that's why we could say that the rate is faster. So this one has a faster rate of reaction. So from here, we can select the option from the second column, that one that involves bromine. It is a correct option from the second column. Now we have to find the answer of the second part, that is the first column. What shall be the percentage value, percentage yield of the product X? So basically, it is related with the formula that percentage yield is basically calculated as actual yield divided by theoretical yield. Now in the statement, they have already mentioned that this much mass of the original compound forms 12.32 gram of the product X. Now this is the actual yield. We have to determine the theoretical yield. From there, we will find the percentage yield. How do we determine the theoretical yield? We need to take the ratio method here, and that ratio is between the compound mentioned in statement 1, that is 2-bromo 2-methyl compound. It has to be taken as ratio with respect to the product. Now, I will represent the compound, the 2-bromo 2-methylbutane. This is a compound. We have bromine on the second carbon, and also the OH is also attached on the second carbon. Methyl group is also attached on the second carbon. So this is 2-bromo to methylbutane. You can attach the hydrogen atoms on the remaining position of the carbon, and it then converts into the and this is the reaction between the NaOH aqueous. That means the alcohol is formed. So you will have the OH group present on the second carbon instead of bromine, and the rest of the structure will remain the same. Now we have to determine the MR of the product. This is the X product. We are already provided with the value of the MR value for the original compound. We do not have the value of MR of the X compound. This is Xa. So it's simple. You just have to minus the value 150.9. You have to minus the value of the bromine from here and replace it with the value of OH. The bromine AR value, the AR value of bromine is 79.9, and that AR value, or we could say MR value of OH is 17. So just do the calculation. 150.9 minus 79.9 minus this value of the bromine and add the value of the OH, because this is what we are replacing it. So when you do the calculation, the MR value of this compound will come out to be 88. The value is equivalent to 88. That means that compound X has MR value equal to 88. Now do the ratio method. That means we have to take the ratio of the compound, bromine compound, that has 150.9 gram as its MR value, ratio, this is MR value of the compound bromine compound, and the MR value of the product X has 88 as the mass MR. Now, according to the information provided, they are saying that 12.32 gram of the product X was obtained. So we would say that the this is the actual yield. We have to use this value, we have to use this value, that how much mass of the compound X will be produced when you have 30.18 gram of the bromine compound. So you take the value here, 30.18 gram. If this is the mass of the compound provided, and how much value of the compound X will be produced, that will give you the theoretical yield. We are trying to find the theoretical yield using these calculations. So if you calculate X value, it will be equivalent to 30.18 into 88 divided by 150.9. The answer comes out to be equivalent to 17.6 gram. So this is the mass of the compound X produced as theoretical yield. Now we have to calculate the percentage yield. So the formula is simple. Percentage yield is equal to actual yield divided by theoretical yield. The actual yield was 12.32 and theoretical yield is 17.6 into 100 multiplied by 100. The answer comes out to be equal to 70%. So from the first column, we will select the 70. So the only correct option is the C option, having 2 ticks. Now the next question is question number 36. It states an alkene P reacts with an excess of hot concentrated KMnO4, and then this is the only product formed as a result of this reaction. We have to tell which compound is alkene P. So we have the given option and we have to find out the answer from the given options. For this purpose, we need to understand what shall be the reaction type, what kind of reaction will be between the concentrated acidified KMnO4 with that of alkene mentioned the given compound. So let's start from option A, And before going into that, we need to see the structure of the methyl propanoic acid. I'm going to draw a simple structure. We have 3 carbon atoms like this, and then we have this structure as methyl propanoic acid. You can complete the hydrogen atoms on the carbon atoms shown here. This is methyl propanoic acid. So this is a product which should be obtained by the reaction of acidified KMnO4 with a given option. So I'm going to start from option B first. The option B says S2-methyl butene. So let's draw the structure first. The methyl part should come on carbon number 2 like this. And butene means double bond is also present carbon number 2. Now if KMnO4 is reactive with this compound, then it should leave the compound from this point, and as a result of this, we should have 2 products formed. We should have carbon, we should have a ketone. This one will be a ketone, and another product will be obtained from this part of the compound that should give us ethanoic acid. So we will have these 2 compounds or these 2 products obtained as a result of the reaction. So B is not the correct answer because we should have this compound form as a result of the reaction, and this is not what we are getting from here. Now let's check the option C. The option C says is methyl propene. The structure of this is we have methyl propene, so carbon methyl group on this carbon and then double bond here. You can place double bond either here or on the left side. That both will give you the same structure. Now, when this compound goes through reaction with KMnO4, it shall produce again another ketone like this. And along with that, this part will become first into the methanoic acid. And later it will convert into the carbon dioxide and water. Because it is being reacted with the excess of the hot concentrated KMnO4. Then the D part is an oct-4-ene. The structure is simple like this. We have 8 carbon atoms in straight chain. Now on this straight chain, we have double bond at position number 4. This is the point where double bond is present. Now when KMnO4 reacts on this part, it shall produce 2 similar products, but that will not be the required compound which we require, that is a methyl propanoic acid. Instead, we will get on the butanoic acids. So as a result of the reaction, we shall get only the butanoic acid. So again, D is not the correct answer. C was also not the correct answer. Now let's check the compound A. It says the structure looks like this. 2,5-dimethyl hex 3-ene. So I'm going to draw that structure. We have in straight chain, we have 6 carbon atoms. And then position number 2 and 5, we have the 2 methyl groups. This is position number 2, and this is position number 5. So on position number 5, position number 2, we had methyl group, and then on position number 3, we had a double bond. So this is position number 3. Now, as a result of this compound goes through KMnO4, I have to raise. We will get cleavage from this point, and that shall produce initially the aldehyde and secondly into the carboxylic acid. So the product will be something like this. Now this is the product form as a result of both the parts of both the sides of the structure, the left side and the right side, and that structure resembles totally like this. So that's why A is a Correct answer. I can show the same formation to in a separate space. So this was the compound that we initially had. So this was the structure initially. And we had to clear the compound from this point, and when it cleared, it produced initially the aldehyde like this, and that was then later on converted into the carboxylic acid, and that is the actual answer. Now the question number 37. Now question number 37 states, three substances are listed, and these are the three substances. Which substances are possible products of the free radical substitution between ethene and bromine? Now we have to understand the reaction between the ethane with that of the bromine. So this is ethane reacting with the bromine in free radical substitution reaction, and as a result of this, we do remember that it used to produce the free radicals, and the free radical was basically obtained by the breaking of the bromine to bromine molecule. This was broken up by using the ultraviolet light, and it produced the bromine radical. Then that bromine radical reacted with the ethene molecule, and it produced the HBr. It produced HBr. Along with that, the ethyl radical was produced like this. So this is a ethyl radical produced. Now we have got one product listed here, that is HBr. But there is no way in which the hydrogen could be formed, that is H2. H2 does not form in such a reaction because there is no way in which the hydrogen radical is formed. Only the bromine radical is formed in the reaction, not the hydrogen radical. So 2 is wrong. Now let's check butane. So during the reaction, as we said, that ethyl radical is produced. So when the termination reaction is there, in the termination reaction, we used to have different combinations of the radicals reacting with each other. It could be we could say it is a bromine radical reacting with the ethyl radical, or we could have we could have bromine radical reacting with another bromine radical, or we could have ethyl radical reacting with the ethyl radical. That's also possible. So ethyl radical reacting with another ethyl radical. And when this happens, we can have a formation of the butane. So this is how butane is formed when two ethyl free radicals are reactive with each other. So the statement 1 is also correct. So when 1 and 3 are correct, that means the correct option becomes the C option. Now, next question, number 38. The structure of the testosterone molecule is shown. Which statements are correct? Now here, we have to check again the three statements mentioned here. we have first statement that says carbon atoms C1 and C2 can be oxidized with acidified K2Cr27. So basically, if we look at these carbon 1 and the carbon 1 indicates it's a ketone molecule. The ketone cannot be reacted with a K2Cr2O7. There is no reaction. I would say reaction between ketone and K2Cr27 has no reaction. So statement 1 becomes wrong with respect to C1. And what was with respect to C2? C2 states it's an alcohol. C2 contains OH group, so yes, it can be oxidized with K2Cr27, and when it does, it will first convert into aldehyde. And later it will convert into carboxylic acid. So this can be done. So second part of this first statement is correct, but overall statement 1 is incorrect. Now let's check statement 2. Let's say there are fewer than 27 hydrogen atoms in one testosterone molecule. So let's check how many hydrogen atoms are there. For that purpose, I will indicate all the hydrogen atoms that are present in this molecule. So here we have, I will just label the hydrogen atoms present in this molecule. We have 2 hydrogen atoms present here, 2 over here, 2 over here, 2, and then all these points have 2 hydrogen atoms each. Now, which parts have only 1 hydrogen atoms? This has 1, 1, 1, 1, and 1. All these points have 1 hydrogen atom each. Now let's count them. And yeah, 1 more hydrogen atom is also present at this point over here. Now let's count them. We have 1, 3, 1 plus 2 is 3, 5, 7, 9, 11, 13, 15, 17, and then 18, 19, 20, 21, 22, and then add these numbers. Starting from here, I will first add this one. 22 plus 3 is 25. And then these 3, 25 plus 3 is 28. I have one mistake over here. There is no hydrogen atom present here. Just to let you know, there is no hydrogen atom at here because the carbon is already making 4 bonds. So yeah, there is this one slide mistake that occurred. Okay, then 20, I will minus 1 hydrogen at the end, so 28, and then this one, 29, and if you just minus 1 hydrogen that was mentioned previously at this point, so it will become 28. So we have a total 28 hydrogen atoms. So according to that, the statement 2 becomes wrong because it has fewer than 27, so that's wrong. Instead, it has more than 27. Now, the third statement says there are 6 chiral carbon atoms in one testosterone molecule. Now, also check how many carbon atoms over here how many of the carbon atoms in this molecule are chiral. So I have to raise all of this working to find the chiral carbons. All right, now here we need to find all those carbons which are bonded with 4 different groups. So here we have them. This is chiral carbon because it is bonded with 4 different groups. This is one group, this is another group, this is another group, and this one has a hydrogen as well. So that's why it's a chiral carbon. Now this is also chiral carbon attached with 4 different groups, including one hydrogen atom. This is also a chiral carbon attached with 4 different groups. And then this one, chiral carbon. This is also a chiral carbon. So we have now 1, 2, 3, 4, 5. And one more is mentioned over here. It has also 4 different groups attached with. So in total, we have only these 6 chiral carbons present in the molecule. And there is no other point where the chiral carbons are present because they all are attached with 4 different groups. So that's why we can say the third statement is the correct option. The third statement. That means the correct option becomes the D option. Now the next question, the structure formula of hept-1,4-triene is shown. How many of the carbon atoms in one molecule of hept-1,4-triene are sp2 hybridized? Now let's check that. We remember that all those carbon atoms which have such a situation which carbon is double bonded and it is bonded with only 3 atoms, A, B, and C. I will not write C here. I can write it like D because these are represented as 3 different elements or 3 different atoms. When such a situation occurs, then such a carbon is said to be sp2 hybridized. So this carbon is sp2 hybridized, in which the carbon is double bonded from one point and it has in total 3 bonds bonded with it. Such a situation occurred in all the molecules of alkene. We had such a situation in alkenes. Now let's elaborate this structure into displayed formula. Only then we can understand the actual picture. So I will first write all the carbon atoms in straight chain. We have in total how many carbon atoms? 1, 2, 3, 4, 5, 6, and 7. We have in total 7 carbon atoms. So let's draw them. 1, 2, 3, 4, 5, 6, and 7. Now show the hydrogen atoms accordingly. So the first carbon atom has 2 hydrogen atoms on it, these 2. Then the second carbon has only 1 H, like this. The third carbon has 2 hydrogen atoms, these 2. The fourth carbon atom has 1 H. And then the next carbon has no hydrogen on it. And then the second last carbon has 1 hydrogen. And at the last one, the rightmost carbon has 3 hydrogens. So this is the situation we have. I have not mentioned the hydrogens to make it simple. Now you have to decide where the double bond should occur. We can see here that double bond should occur at this point. Only then the valency of the left carbon will be completed. Also, the valency of the right carbon has also been completed. Now let's move on. This carbon has already 4 bonds, so it will not have double bond. This carbon will have a double bond because the valency of this carbon is not completed yet. So put a double bond over here. So now this is a double bond present. Now with respect to this carbon which has no hydrogen bonded on it, it must have 2 double bonds on either side, one on the left side and the other one on the right side. So let's put another double bond over here. So this carbon has 2 double bonds. Now and this carbon valency also completed and this carbon has already completed valency. That means in total we should have 3 double covalent bonds. Now according to that, we have to decide how many carbon atoms are there with the sp2 hybridization. As we said before, that this is a situation that should be present in the molecule, only then the carbon is said to be having sp2 hybridized. So if we start from this carbon, we can clearly see that this carbon has the sp2 hybridization because it is bonded with 3 atoms. It is attached with 2 hydrogen atoms and with 1 carbon atom. That means the leftmost carbon is sp2. Then adjacent to this carbon is this one. It is also sp2. It is also having double bond, and it is also bonded with 2 more carbon atoms. Sorry, with 2 more atoms. 1 hydrogen above, an alkyl group on the right, and alkyl group on the left side. Or you could say 2 carbon atoms on left and right, and 1 hydrogen above. So that's why this carbon is also sp2 hybridized. Then skipping this carbon because it is bonded with 4 different atoms, it is not sp2. Then this carbon, it has double bond and it is bonded with 3 more atoms, the right carbon, the left carbon, and above hydrogen. So this one is sp2 hybridized. And then this carbon, if we skip this carbon and move on to this carbon, it is also bonded to double bond and 3 atoms, 1 carbon left, right, 1 carbon left, and 1 hydrogen above. So this is also sp2. Now there is a situation about this carbon. What should we say about this carbon, which has 2 double covalent bonds on either sides? That means it is actually not sp2. It is not sp2 because this carbon is bonded with only 2 carbon with 2 more atoms. It has 1 atom on the left side and another atom on the right side. So it is not fulfilling the condition which we required over here, having 3 different atoms bonded with a central carbon. Rather, we can see there are only 2 atoms bonded on the left and right side. So as a result of this, the hybridization that is actually appeared on this carbon is sp3. It is sp, not sp2, it is sp. So because of this reason, we will not count that carbon as the sp2. It is, sorry, it is sp only. This is sp. So let's count how many carbon atoms are sp2. We have this one, 1, 2, 3, and 4. So we have 4. So that's why A is the correct option. Now the last question of this paper, hydrocarbon X is saturated. Each molecule contains 1 ring of carbon atoms. The mass spectrum of hydrogen X is measured. The peak representing the M+1 ion is 14 mm high. The peak representing M+1 cation is 0.7 mm high. What is the M by E value for the M+ ion of X? All right, now this question belongs to analytical chemistry, and in that it belongs to mass spectrometry. Now, basically, we are provided some of the information which we have to use. We should know that the compound X is totally hydrocarbon. That means it has only hydrogen and carbon atoms and no other element is there. And it is saturated. That means it should be an alkane compound. So we have only the alkane compound present in this case. Now, according to that, and one more thing, that is, it has a ring present in the compound. There's only 1 ring of the carbon atoms. That means it should be something circular molecule or closed structure of the hydrocarbon that we have to find. Now, basically, they have provided value for the M+ ion and M+1 ion, or we could say M cation and M+1 cation. You can read them as M cation, and this one is written as set as M+1 cation because all the ions in the mass spectrometry are cations only. Now, these values, what they have to do, they are basically the abundance we would say these are the abundance because they are representing the peaks, and peaks are always the abundance of that particular species. So if they have provided us the abundance of these two species, that means we have to use a formula that should include the abundance. Now, the formula related to it was N is equal to 100 plus 100 into abundance of M plus 1 cation divided by 1.1 into abundance of M plus cation. We can write M plus 1 whole cation and M plus ion. This is the formula, and the value N is basically indicating the number of carbon atoms. So from this formula, we can understand how many carbon atoms there would be in the compound, and from there we can find the mass of that molecule. This is the molecular ion peak. That means it's the actual compound with M by E value. So when you put the values, so what value should we should put here? For M plus 1, we should write 0.77 mm high because this is the only amount we have here. So 100 times 0.77 divided by the value of M plus is 14 mm. 14 mm for M plus ion. When you put here 1.1 into 14. Now, when you do the calculation, you will get the answer equivalent to 5. So the answer will be 5. That means there are 5 carbon atoms. There are 5 carbon atoms in the hydrocarbon molecule, and that hydrocarbon is basically ring structure. So we can easily have this type of the compound. This is the skeletal formula, or in display formula. This is the display formula having 5 carbon atom. Now it says it's a saturated. That means there should be no double bond, and all the carbon atoms must be bonded with the hydrogen. So just add the hydrogen atoms like this. Now you can clearly see that there is basically 5 carbon atoms and 10 hydrogen atoms. Now just add the mass of these. So 5 into 12 plus 10. It is equivalent to 70. So the correct answer becomes 70. C is the correct answer. So this was the last question of this paper. I hope I have cleared all the queries of this paper to all the students. If you still have any doubts about any question, you can let me know in the comment section, or you can reach me out on my provided WhatsApp number, as you can see on the screen. I will come back with another video for this Majon seed, and you can already have the solved paper of paper second variant of this exam series. So that's all for today, students. If you want any group classes or one-to-one classes, you can reach me out on my WhatsApp number as well. Till my next class, take care and bye-bye, everyone.